So this problem, we're starting to change gears a little bit. They're telling us that there's 54% of people own dogs. Now, they don't tell us whether this is an experimental probability or a theoretical probability. We're just going to go with it. It's probably based in past data or collected data, so it's probably experimental or empirical. But so now what's different about this is we want to pick two people at random, and what's the probability that they both own a dog? Now we're going to assume that these two people they pick at random are independent. In other words, what one does, the other doesn't. It doesn't affect the other. So what we can do with this situation is we can say, so for the first person, there's a 54% chance or a 0.54 probability they'll have a dog. And then for the second person, we can assume that there's no change, that they have just an equal likely probability of owning a dog. So we're multiplying 0.54 times 0.54 because that's what they're telling us the probability is. And just so you know, it's the same as taking 0.54 raised to the second power, right? So when I do this in my calculator, let's see. So I'm going to take 0.54 raised to the second. So I'm getting 0.2916. So that's equal to 0.2916. And that makes sense because it's about half of 54. I mean, a little more than that. And so they want at least 3 decimal places. I would try putting all 4 of those into that answer box. Okay? So when you're dealing with more than 2 people, if you have 3 people, I would raise it to the third power, multiply it by itself 3 times. Okay, this probability doesn't change in this case because the important thing, I said it, these are independent events. Independent events. Now, how did I know to multiply them and not add them? Well, because it's 2 people, this is an and event. It's this person and that person. So usually when you have to deal with an and probability, you're multiplying the probabilities. So I hope that helps you out.